I think you can start it.
Okay, so today we're going to solve a pretty famous question called decode ways. So basically you are given a string, and based on the alphabet from A to Z, you want to return the number of ways you can make 12. So for example, A and B, 1 and 2, or just L is 12 because A, B, C, D, E, F, G, H, I, J, K, L is the 12th number of the letter in the alphabet. So we want the number of ways to decode it. To me, that sounds like dynamic programming, because there could be multiple ways to do the same thing, and we want to catch all of them. And we have an edge case here where if the leading digit is a 0, then we can just return 0 because there's no mapping to any number with a leading 0. So yeah, this is a dynamic programming question. What we are going to do is first take care of the edge case. So we have a string here. If s of 0 is equal to 0, we can return 0 right away. That's not the case, then let's build up an array for dynamic programming. So we can call this input length equals to length of s, like the input, and we want to do +1 because that would be a boundary check. This would be an edge case. This is a +1 because this is an index. And then we have to set our base cases. So we know that there are 0 ways to decode 0 strings, and there's 0 ways to decode an empty string, and there's also 0 ways to decode one string.
Mm-hmm.
So these are the base cases of our dynamic programming. And just because this is DP1 doesn't mean that that's the answer, because we're going to build on top of that. And we are actually going to iterate from 2 to the input length +1, because we've already defined our 2 base cases, so we can start from 2. This is almost like the coin change problem, and now we have a bit of an edge case. So if it's a single digit, then there's only one way to make it up, because there's only one way to get 9. But if it's a double digit, then there's going to be multiple ways. So cool. So now we have to say current number equals to s of I minus 1. Or let's say this is, okay, a single digit integer s I minus 1 to I. And then we have to check that it's in bounds. So if 0 is less than or equal to single digit, is less than or equal to 9, because 10 is the first double digit that starts, and 1 because our base case was taken care of with 0. If this is true, then we can add to our current DP array the previous, because we're building up that array. So, and then for double digit cases, same thing. Double digit less than 26, because 26 letters in the alphabet, we are going to add dp of I minus 2. And then at the end, going to return dp of input length, because that's a lengthy input. So there you go. Oops, sorry, I misspelled this.
Okay. Because the input length.
Oops.
The name input length is not defined. I think number 5. Or number 4, okay.
Hold on. One second.
Yeah, it's fine. Take your time.
So it was spelled incorrectly. Here. Out of range. Okay. So
It's out of range.
maybe I thought it was. Is it +1 or is it what? Oh, that's why. Because
Okay.
is not digit. So again, keep spelling this wrong. Okay.
It's very,
So okay. Oh, see, I made a mistake here. It's supposed to be one way because there's one way to decode one string, and there's also one way to decode 0 strings, which is to not decode it. Okay,
it's
so
better.
almost there.
Yeah.
But there's another bug because right now it's supposed to be less than or equal to 26 because 26 is inclusive. There you go. Because 26 is going to be the last letter. So
Yeah, correct. Yeah. So
there you go.
you are using the dynamic programming. Okay.
Yeah.
Did you use the memorization?
No, this is not memorization. Do you know the coin change problem is very similar? You basically build up. It's like a bottom-up approach, right?
You are you bottom
Number of
up.
ways
Okay.
to make up 0, number of ways to make up length 1, all the way up to the input length.
Oh, okay. Okay. You you are using you just create array. My solution just call the function again and again. That's why I need a memorization.
No, this is not memorization. This is not using recursion. This is an iterative solution.
Yeah, iterate. Yeah, we are using different ways, but it's similar. Yeah. Okay. Can you tell me the time complexity?
Time complexity is O(n) because we're only iterating through the input string once. And space complexity is O(n) as well, or O(1) because other than this DP variable, we're not really storing anything else. So
Yeah, I think. Okay, I think it's good. Now I start